Welcome back to the making of Victoria, the automaton. I have now finished designing the neck on the computer using 3D Builder and 2D Design. Right, let's have a look at the other version, the 2D version of this. Here's the 2D version. As you can see, handily labelled. You can see it's made of lots and lots of little green lines that are 0.15mm apart. Quite useful because 2D Design you can hatch it on CAD software. So I just use the hatching fill, and the laser software doesn't see it as that, it just sees it as lots of lines. So it's going to engrave those down to about 1mm deep, and then the black lines it will then cut out. So let's go and cut that out. So here's the finished item, and you can see that there are the two rebates, they're about 1mm deep. Here's the lovely little motor, and what I'm hoping is poke the wires through there, and then this should, oh look at that, that's so satisfying. It just fits perfectly. If you look at the shape of the drive shaft on the motor, you can see it's got that's 5mm diameter with two flat sides and a 2mm base that's still round. So ideally, I don't want to have to start machining brass bits like I've done in the past to fix on linkages and things. I want to cut this shape out of the acrylic gear tight enough so it'll push on firmly, and then I can fix it on with just a couple of drops of super glue. So here's the 3D representation of the gear I'm going to cut out. 11 teeth with this funny little bit in the centre. I imported this via a bitmap from 2D Design. Unfortunately I can't do it the other way around, from 3D Builder back into 2D Design I can't do it. Here's the gear in 2D Design, and you can see, if I zoom in, there's the same thing that we had just now with the hatching that's going to cut the circular rebate ready for the shaft to go in. So I'll export that and cut it out. So there you have it. There's the gear that's cut out, and hopefully it will just yes, just pushes on. I can't get it too close with this lens, but you can see the circular bit's gone into it and the end bit is sticking out. Originally I was going to make the gears out of 10mm acrylic just because I want them to be really reliable and have more double the bearing surface, basically less likely to wear out. Probably not a problem, but I thought I'd overdo it anyway. But when I tried to cut out the gears from 10mm acrylic, wasn't very successful because of the distortion. Some of them were worse than others. You even, because it gets so hot, some of the bottoms of the teeth, they're also bent over and things. I gave up in the end. I tried it several times, but in the end 5mm was so much better. There's no distortion at all. Well, that's a good sign, that's nice and firm. There's no distortion, the teeth are really clean. And then I went ahead and I thought, hang on a minute, why not just cut out two 5mm teeth and stick them together? So that's what I'm going to do. This is just a little drive shaft I was using to experiment with, and then glue them together and they will be perfect, especially if I get them lined up properly. That's going to drive their head up and down as well, and I've had the same problem spending ages cutting loads and loads of little hexagonal holes until I found one I was happy with for the quarter millimeter thick hex rod. Quarter inch, 6.3mm. Rolls off the tongue nicely. I'm going to do the same with that, so I'm happy with the size of this. Thing is, it's worth experimenting, because once you've established the right size you can then copy it over to future designs. Right, so we've got all these little bits and pieces done. I feel some 3D printing coming on, and it is so exciting. Oh, the other thing that arrived, which is brilliant, is the Lazy Susan bearing. And this is absolutely fantastic. I hoped it would be, Like I said in the last video, previously I'd used pressed steel ones. This isn't, this is machined out of 2 pieces of aluminium, and the balls, as you can just see here, you can just see the balls. It'd be a shame they're not more visible, but you can't have everything. They're trapped between the two, and it is superb. I can definitely recommend these. Beautiful. And because they're trapped within it, you can turn it either way around, and it'll take forces, downward forces, upward forces, lateral forces, no effect at all. It is beautiful. Oh, one little aside, I discovered that you can paint these anyway in all different colours, but I've only ever used just flat colours. I discovered you can colour things so that they are actually metallic. Absolutely incredible. So this dome nut, which was really quick and easy to draw, you paint it in metallic brass. It's fabulous. It just makes it look so good, and the wood as well. Fantastic. Anywho, back to this. What I realised was, obviously I need a limit switch like we were talking about before, so that as the head angles down, I need it to be able to tell the Arduino, the controller, microcontroller, where 0 is in effect. So what I did, right, spin around, a little microswitch in it. I just modelled the microswitch and then hollowed it out, subtracted it from this little shape here, and again with experimentation to check that I'd got it the right size. And once I had, it was brilliant. There's also one other, before I go on, one other little useful top tip is, as you can see from this side of the neck, if I try and print this from the bottom, which I will do, it'll print all the way up happily, and then if I've got an overhang that's just horizontal, the first fibres aren't going to be able to have anything to stick to, so they're going to just end up with a pile of spaghetti and eventually possibly some sort of semblance of this. But what I did was to use the slicing tool on about a 20-degree angle. I found is very, very good. And what it means is that as this slices up, it can start laying down a little bit at a time extra, and it prints it perfectly. There's a little angle there, and that's all it takes. Because this is angled out, it's absolutely fine. Done the same thing in the bearing holder part. It was so easy. I was thinking about having to create a triangle and fixing it on and all sorts of other bits and pieces, but no, you just need to make sure you've got enough room and then use the slicing tool just to slice a little bit off it, and there we have it again. And that's enough. It will then print perfectly, and with these little cable hooks here, these little cable supports, angle perfect, about 20 degrees will do it. So what I'm going to do now is I want to print this bit. Oh, it's just a joy. It really is. It is just amazing. If I try and select this, because I'm getting all flustered here. No, right, let's have a look then. Let's move this back that way so we can have a look at it. Right. This is a multi-purpose thing. It's going to support the gear, this large gear here, there, and it's going to activate the microswitch that you just saw on the other side. And it's just so amazing because someone very kindly put up a free to download M4 screw thread. I've enlarged it by about 0.2 millimeters, and I found that then if you subtract this from a piece of plastic, it leaves you with the perfect printed thread that works beautifully. I mean, how amazing is that? You can print this shape and you can even print the threads in it. I've just put this one back in. Let's ungroup it and I'll show you what I mean. There we are. So there's a thread I've just put in because it looks nice, especially when it's metallic and looks like brass. It is just fabulous. The realism, incredible. But basically you drop that into a piece of plastic, so I'll step back again, but just to demonstrate, so I can drop that down here, and like I say, this is 0.2 millimeters bigger, not longer. I just increased it, the X and Y, not the Z, because I wanted the pitch to stay the same, if that makes any sense. So there we are. Look, I've dropped this thread through here. All I need to do is to go to Edit and Subtract. Look at that, and that will actually print the thread. That is amazing. Right, so there it is in the printing software, the slicing software. It says it's going to take 18 minutes and use 1.12 meters of fibre, 3 grams of fibre. So that's fine. So I'm just going to click on save as G-code. It's as simple as that. I'm going to switch the laser cutter noise off and swap it with the 3D printer noise, which is a nice little whirring sound. Then I'm going to preheat PLA, which is the type of plastic. And what that does, it warms up the bed of the machine, which is that, to 60 degrees C for PLA, and that makes it stick, the printed plastic to stick on this without sort of losing grip and flying all over the place. And it heats up the little nozzle, extruding nozzle in there, to 215 degrees Celsius. I'm just going to scrape off the remainder of previous things I've printed. As you can see, it's warming up. It's now 199 degrees Celsius and 45 degrees Celsius. I'm going to go to print from TF, which is the little card, and hex switch lever. Here we are. Come on, lines. Right, hex switch lever. I've stopped the print because I thought it would be interesting just to show. I'll get me a spatula. Yeah. Just to show how these amazing 3D printers create objects. So you can see it's got, don't know, 3.7 millimeters up, it says, and you can see it prints a solid base on the bottom, and then fills all the gaps in with webbing. You can dictate. You can say I want 20% of the inside filled, or less, or more. You can have 100% if you want it absolutely solid. Here's one I prepared earlier. There it is. This is what it's going to look like. And I've put screws in it just to make sure that the threads did print properly, and they did. Just right, not too loose, not too tight. So from the original M4 design, 3D design, just increase the X and the Y by 0.2 millimeters I've found, and then that is perfect. It's amazing. How absolutely fabulous. Look at that. So there's the finished printed neck, which I think took 8 or 9 hours, something like that. I'm so pleased. My fibre tensioner repair carried on going, so I didn't waste loads of plastic. There's little holes there for wires to be guided down through, so they don't get in the way of anything. There's the Microswitch slot and bearing holders. Oh, it's just brilliant. I'm so pleased. It really is very, very tough. I've got a little row of holes down around the bottom for these little copper rivets, because I had them on Florence and they look great, and that's perfect. They just fit in the hole, they push in perfectly without any fiddling around, and there's a little hole at the back so I can put a drop of super glue to hold them. However, I think that these holes, yeah, the M4 screw holes that are going to fix this onto the next bit, they're just too small, so I think I'm going to go and use my unfeasibly long 4mm drill bit. Look at the size of this. Oh, missus. Very useful for some things, for example this job, because I can't stand it that well, and I could risk balancing on the edge, but then there's a little step here, so that's not going to work. So it really does need to be flat on a surface. Wibbly wobbly, but never mind. Try and get my hand out of the shot whilst working the controls. Sure enough, they do. During the meanwhilst, I've been cutting out all the other bits and pieces. Yes, it's all so exciting. I've got my motors, got my Microswitch, which is going to do the sensing for one of the motors. Got a base bit. I've cut out 2 bits of wood. I've got another thing I printed to hold the other motor down and all the gears, and I say that lazy Susan Mering, it is so exciting because it's now time to start putting this all together and see whether it works, what needs to be improved. I've got stuck before I even started. That's the motor, the first one. I've put the push I haven't glued them on yet, just in case. This fits perfectly up inside. If I can get it lined up like so, that's perfect. That will then be adjustable. But I haven't got any ways of getting a screw, an M4 screw, into the side. I didn't want to have any holes on the outside. That would have made it a lot easier, but it would have spoiled the look. After fiddling around for ages trying to get a variety of screws into those two holes, I gave up and drilled two little holes. Perhaps Victoria can have a couple of little beauty spots on her neck or something, I don't know. But it was so much easier. I just made them the right size to get a small screwdriver through, and once I had that forcing and twisting, the screws went in perfectly. So you can see there's the motor mounted inside, and it pivots up and down somehow. How can I show you that? Well, yeah, it does pivot up and down, so I can accurately adjust this gear to make sure it engages properly on the next gear up. Here's one of the bearings, the beautiful bearings that I'm going to use to support the head, and let's see whether they actually push in. Oh, look at that. I mean, oh, joy unbounded. It is amazing. Again, I did this with lots of experiments to get exactly the right size, just printing a little bit with a circle in it just to get the right, but that is, oh, that one, yeah, look at that. And it just sits in there. Oh, joy. And then what about, here's the little micro switch. Let's just try that. Oh, God, I tell you, it doesn't get much better than this. So I'll get the, I printed out those little, although everything's getting a little bit mixed up here. Oh, surprise, surprise. Two of these which have got the hexagon in the middle for the brass hex rod, and the outside should just, yeah, so that fits inside. I've designed and printed the two new spacers, the bearing supports, the hexagonal bearing supports and the spacers, and you can see where this actually fits into the bearing, like so. I've just added a little ridge there so it can't push any more that way. It'll also hold the bearing into the socket, and I did that by using the cone tool. That's the cone tool on 3D Builder, so it's an inverted upside down cone. Well, I cut a hole in, hollowed out the middle, and then just got it to the right position. That's perfect because, like I was saying before, as this printed from the bottom up, it printed that perfectly. There was no overhang. If I'd tried to print it this way up, it would have started trying to print outwards and been piles of little plastic spaghetti everywhere. So see how well it all fits together. Also, I just realised that once I put the shaft through here, I won't be able to get the microswitch out, so I've soldered a couple of wires onto it, so that when that pushes down, that can let the Arduino know that the head has reached its limit, so I can put that in and then assemble everything. So it's all assembled. I've got my calculations a little bit wrong by about 1 millimetre, so there's a little bit of movement from side to side, but that's not bad. I could also just slide that along. Right, I've got the Arduino wired up. There's the Arduino. Here's the microswitch wires, and I have connected them to, don't know whether it's going to focus or anything, but they go to between ground, which is 0 volts, and I've decided that A4 is going to be an input, digital input. I mean, that's what amazes me about this. And I know it's all old hat these days, but you don't, all the inputs and outputs can be either. I think they're called GPIO, general purpose input output, and you can just decide with the software what each one does. So A0, 1, 2, 3, they're the outputs to drive the little interface for the stepper motor, and then A4 is going to be the input from the limit switch for the stepper motor. Absolutely amazing. Now, because I don't want to risk getting these wired up wrong, like the direction of this or the switch being in the wrong position, so this grinds itself around and shreds the motor or damages anything, I just want to check the first thing. The first thing is the limit switch. So what I've got here in the setup part of it there, it just says, forget about the stepper motor, the head stepper, just said pin mode A4 input pull up. That means it's going to have inside the Arduino a resistor connected to try and always pull it up to positive, so it doesn't float somewhere. It always knows that it's either going to be pulled up to positive with a 10k resistor inside it, or if you short it to 0 volts to ground, then it's going to go straight to 0 volts. Then I've got serial begin, and serial is a way of the Arduino printing back information to the computer while it's connected. And then as it loops round and round and round, forget all the grayed out stuff, that's all to do with the stepper. I've just got it print line, then waiting half a second, and printing another line, digital read A4, so just printing what it sees on A4. So let's upload that and see what it does. There we are, not touching the switch, and it is 1, so it's the resistor inside is pulling it up to 1, which is positive. If I push the switch, it goes to negative. Let go, positive, or 1. Press the switch, pulls it down to ground, so that goes to 0, digital 0, digital 1, whatever, on and off basically. So that is fantastic. I now know that I need to get the stepper motor turning until the switch goes to 0 volts, until the switch reads 0. So what Setup Motors does, it tells it to switch on the outputs to the stepper motor, then set maximum speed 1000. This is the speed I want it to go this fast when it's working at full speed. Acceleration is 100, I've found, that works really nicely for these little motors. Set stepper, I've said the current position is 0 because I don't know where it is when you first switch on. It could be anywhere. Then I've said move to minus 5000. That, from my previous test, means that it's going to be tilting forwards, so towards the micro switch. So it's going to keep doing that, keep running it while the digital read is high. That means it's not touching the micro switch. As soon as the lever touches the micro switch, that goes low, and it's going to stop doing that and jump to the next one, which is set current position to 0. So we now know that looking right down, as far as down as you can look, it'll be 0. Then it's going to move all the way looking up, just out of an experiment. I just wanted to see what that is, and I found it's roughly about 1800. Do that until the distance to go is 0, and then stop and switch the outputs off. So let's try that. So we don't know where it is. The Arduino hasn't got a clue where it is at the moment. So uploading it, and then it'll start working. And if there we are, right. Well, you can just see the little lights flickering. Right, it's come forward, you can hear it click, so it now knows to stop. Now it's going to go as far back as it can, and then stop. Now that's great, that's really good. Let's have an action replay, but from the side this time. So it doesn't know where it is, goes forward, clicks the switch, and then goes all the way back. That means by keeping account of how many steps back and forward I move it, or it has moved, I know exactly where it is every single time I want to move it. So I've cut out on the laser cutter 2 bits of 3mm ply, and what I'm going to do is I'm going to fix the outer one to these pieces of ply, so that is fixed, and the neck is going to go on here. So the neck's going to go on there, like that, so that's going to turn. In order to get that turning, what I'm going to do, is cunning plan, is to use these two, just like I was saying, it was going to be out of 10mm thick, but no, it's 2 lots of 5s. Fix that in, so this, in effect, this gear is now fixed to the outside, and this is still free to turn. Then this bit, which is going to support the head, or the neck rather, I can't remember which way around it goes now, that is going to have another lovely little 3D printed thing that's going to hold the motor like this, down like that. Again, I can slide it so I can adjust it, the gears, to bear on the inside of the teeth so it meshes properly. So here we are. I've just plugged this stepper motor in rather than the other one, and I've got it on the example bounce sketch that came with this stepper library, and it is working a treat. Look at that. Fantastic. So the outer part can be fixed to some sort of wooden cabinet that supports the whole thing, and the head will screw on to those and be able to turn. And I can get that, should be able to just, if all my calculations are correct, it should fit. Oh yeah, it does. Brilliant. And obviously I haven't put, well, there's no switch on this left to right yet, so she could actually just go round and round and round, knotting all the wires up inside. So my next job is to work out how to let the Arduino know where this is, just because of the limited space in here, because you've got so many bits moving relative to one another, I think. And it's got to fit inside that, of course. It's got to fit inside the hole here. So whatever I do, just thinking, if I had one of the little reed switch magnets cut into some point on this gear underneath, I could then have a little reed switch on the top here, but I think that there might not be room for it. I'll have a think and get back to you on that. I've got the improvements made and I've wired it up for demonstration purposes to the Arduino with a second interface, so I can run both motors at the same time. I managed to, now this plastic bit is made of two pieces, I've managed to rebate the motor a little bit to leave room for another gear, because I realised when it was all put together there wasn't room here for a second gear. So I've done that. I've got the magnet for the reed switch embedded in the top of the gear underneath this, and I've got, there's the Microswitch reed relay. It's got a little cutout there. Because they're quite fragile, I soldered the wires and then just put a blob of hot melt glue in the end just to hold it, so this isn't actually supported by anything. That's probably the safest bet. So when I switch it on now, what happens is it should hunt round to the right without getting stuck until it lines up. There we are. So the reed switch has told the Arduino that it's reached the index point, so to speak, and now it's going to turn back to the front. So that's great. So that's now working. What I'll do now is to put the top on and get them both working together. Right, let's have a look at both motors working. So when I reset the Arduino as it's first switched on, the head finds its index point, and I've just set it to look up. And then brilliant. I'm really looking forward now to starting work on Victoria's head, getting her eyes, mouth, and that's it actually, nothing else moves on your head. Remember, there's lots of things that you can buy that I've made on my website, steamhead.co.uk, or on my Etsy shop, which is Steamhead Inventions. Thanks very much for watching.